Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today we're going to continue working on the Phalanx static bug finder. And one thing I would like to do is, let me pull it up. So, as of right now, we've implemented at least what I think is a good measure of detection for bugs like this, where the it's an index to a static buffer where the index is incremented within a loop. The next step that I would like to go ahead and do is detection for where the pointer itself, not the index, is incremented. From the perspective of the P codes, this might already be done by our detection that we have, but I like to just go ahead and just test it to see it. So let's go ahead and write an instance where a bug like this exists. So just go ahead and copy this and move it over to here. So let's go ahead and do this. How do I want to? Oh, okay, I know. Instead of doing it as an index, actually, this is the pointer that is being dereferenced. So this is the one we care about. We're just going to increment it by 1. No, I can't do that. Can I just add 1 to this pointer address? Wait, no, I can't. I'd have to do something like this. Char target pointer equals target, and then I can do let's see, does this work? It does. Also, pointer and integer. Let's do this. Where it's the address. Okay, never mind now. Cool, so we see this. It's a bug. We go ahead and run it. Cool. So I want to implement detection in this instance where the pointer itself that's being dereferenced is being incremented, not just the index. This might be the same functionality under the hood, so it might already detect it. But let's go ahead and see. So let's throw it at Phalanx and see if the functionality that we already have implemented for bugs where the index is being incremented is already there. Tech import. Okay, let's go ahead and import it. I did not specify to run the postscript, so I'll need to rerun this after importing it. Okay. Let's go ahead and try it now. Okay, let's see. It might already flag it with the functionality that it has in place, but it did not flag it. Okay, cool. That means that we get to have the fun part of going through and actually implementing detection for this. So let's open up the code base that we have here. Currently we have 3 source files for Phalanx. source file for the code iterator context and the actual bug finder itself. And what do we want? Let's start off with just printing the P codes to see what P codes we actually have to work with. For this, this function right here, get P code, just enumerates all the P codes for a function. So I'm just going to go ahead and print them here, appending the string out in front. That way I can easily discern what they are. Oh, misspelled P code here. Okay, let's go ahead and run this. Cannot find symbol. Why? Next. Oh. Didn't fix the typo fully. Okay, let's try this. Okay, here are all the P codes. I'm gonna copy them over to Sublime Text for ease. Wait, no. Okay, here it's gonna branch down. Well, not sure where this is gonna branch in the P code since there isn't really an avid what do you call it? Address to. I can't like tell which P codes are mapped to which address by just looking at the P codes. It's really weird. There's like several different P codes for returning. I wonder if. Wait a second. I think what we're seeing here is we're seeing multiple. Get P codes probably gets called multiple times, so we're seeing the function itself printed multiple times with the P codes. For that, we can just make a print statement right here to detect that. If you see the string printed in between the, actually, yeah, that is probably what's going on. That's the reason why we're getting like this repeated multiple times, yeah. So these are all the P codes we have for the function. So it starts off here, then load, cast, branch, probably down here. But so this is probably going to be the start of the loop right here. Adds a value from the stack, a constant, which that gets fed into this. Which actually, where is the conditional branch? Where is the actual dereference happening? Let's see, cast, load. It's probably happening here. Load. Just gonna quickly go make sure that the Ghidra load P code is the one that I remember it being, where it can actually handle pointer dereferences. Looking at the Ghidra docs right now. Yeah, it is. Input 1 is the. Actually. should be store. Wait, one. Okay, so this dereference is it's getting the let me pull it up. So this load p code is this code right here where it's getting a character from the input array. Storing it in here. Signed extend to here, cast not equal pointer sub conditional branch multi equal. Where is it being stored in? That's the question here. Hang on a second. Let me look at my code editor. From what I understand, the store instruction is where we actually check, yeah, either the store or the pointer add. However, I'm not seeing a store instruction, or store p code here. Pointer sub, conditional branch, add, load, int not equal. Something is off here. Let's first check the let's check the binary. What is the name of the vulnerable function? It's called vuln, of course. What is the address of vuln? It is 1149. Let's check Phalanx to make sure that that is the address that we were scanning. Yeah, 0x101149. It appears that even though the reason why I haven't had to change the address points when I looked at multiple different like binaries is that GCC compiled the vuln function to the same address every time. So that isn't the problem. Problem is that it's not pointer sub conditional branch not equal cast. I'm not seeing. So there's probably either one of two things. Either this is not the correct. Three things. First thing that could potentially be happening right now is this isn't all the P codes that Ghidra has for the function. Number two, Ghidra's P code decompilation for this function is not accurate. Or three, there's some other instruction other than store that's actually handling the dereference pointer right. So for this, I think the first thing that would be good to do is identify the P code in here that is dealing with, what do you call it, incrementing the actual pointer. So this right here, the target pointer plus equals 1. And also this I plus equals 1. So there's two different things being incremented here. Let's see if we can't find, actually, char target pointer equals target. Okay, just looking at here to check quickly if I made a mistake somewhere without even realizing it. So we see here this var node has the constant value 0 written to it, which we see here. Where did my cursor's right here. You see it happens to I, so this var node right here is, it should be the variable I, and let's see if it makes sense. It gets incremented by 1. So since I gets incremented by 1 after the write, this branch instruction probably, well, first off, the conditional happens. So this branch instruction probably branches directly to the actual conditional check being made, and then jumps back up to the start of the loop in which the dereferenced write happens. And we see here that after it, it looks like it pretty much just does a stack canary check and returns. So I don't think we have to worry too much about that. But conditional branch, it's probably code between here and here, this middle part that we actually this middle block is the code that we actually need to look at. Now, up here's anything. What is this unique OX10? 34 unique OX4F00. Does it get? That's probably the what do you call it? The deal something with the stack canary. Okay, cool. So let's continue looking at this. Probably branches down. It'd be probably be helpful for me to add like a print statement here so we can see exactly what the index is. That shouldn't be down here, but I might do that in a second. Sign adds one. See here and add one. So this unique OXBD00, that's what the incremented value of I plus 1 is set equal to, and then we see that I is then again set equal to that, and those are the only two spots that that unique var note is set, so I don't think we have to worry about it. Then we see an assigned extend where it's taking this value of I and feeding it into this register. And then we're seeing that it's adding the I plus this other register, which this other register is most likely input. Let's see. Do we see OX30? I say that it's probably yeah, it's probably input this char pointer right here because of the fact that in order to actually calculate what this input of bracket I is it just takes this offset since each element is just a single byte and just adds that number to the base pointer, so it makes sense that this is the actual operation used to calculate what input of I is. Let's see, casts it into this register and then loads it. For the load instruction, the first argument is the pointer being dereferenced and it's being read and the value is going to OXBB00. We then see that it ends up here, signed extended to here, being casted here to OX0. Okay, here value sign extend cast not equal where is this value coming from? Another potential thing that could have happened. Jump 89. I'm looking at the disassembly right here to see something move. Actually, I'm going to pause this real quick and just install Jeff on this fresh VM BRB. Okay, I'm back. Now, what I'm thinking what might be the reason why I'm not seeing the peak as I expect is GCC could have done something when it was like actually generating the assembly code where it generated or like optimized something out, did something. It generated assembly code that I was not expecting. And as such, the peak generated from that assembly code is not what I'd expect. So for here, let's see if we can look through here to see where it's actually writing. See here, it's the setup jumps to vol plus 89, which is right here. Move a value into EAX, which gets moved into RDX. Value from here is getting moved into RAX. What? This should be just adding one. Hang on a second. Why is it? Hang on a second. It's trying to dereference RAX, which holds this address. However, it should be holding a stack address like this. So, short answer is I probably messed up making the test case. Let's try this instead. I just realized what I was messing up. So, oh, I feel so stupid right now. Issue here was I forgot to put that the value here is equal to this. Yeah. Beforehand, I was just reestablishing that target pointer is the actual pointer itself is equal to the output of here, which that should not be, and then try to dereference that value. Smooth brain mistake on my part. Can't do that. Hang on a second, I want to Google something real quick. Okay, also another smooth brain mistake. When I made the target pointer, it wasn't an actual pointer, so I'm just making so many smooth brain mistakes today. Okay, cool. So here, we're actually saying that, hey, the value pointed to by this pointer, which gets initialized to here, is equal to input of I, and then we increment the target pointer and the index to input. This should do what we want it to. So first, I'm going to delete the project that we've been using for Ghidra. That way we can go ahead and re-import the binaries, since if you try to import, since we're dealing with a new binary, and if we, I forgot if I recompiled the old binary, so I'm going to go ahead and recompile it. But with Ghidra projects, if we go ahead and try to import multiple binaries of the same name, it causes a confliction error. Okay, so now it's definitely been recompiled. Let's go ahead and re-import it. Cool. So let's go ahead and run this. So here are the P codes. Let's go ahead and take a look at these new P codes to see if they are what we expect them to be. The loop is between here and here. So let's go ahead and see. We see an add. Is there a store? Cast load. Store opcode right here. Thank God we are. This works. Okay, so it's being stored. I'm just gonna store opcode. Input 1 holds the address, and for here, that is this pointer add. And we see here, okay, and the pointer is being incremented here with pointer add. We're also saying it's being fed with a multi-equal that's equal to this pointer add, or this other new var node, which is set equal to there. So, okay, how I'm going to do this, let's, first off, since this pointer add is where it's being incremented, we see here that this is the actual opcode that's going to be responsible for doing it. Var node output equals current get output. If this is in a loop, what is the output pointer? Well, so we see here that this unique right here is holding the incremented value, which is then also being subsequently fed into here. And this is the... Okay, so what we're going to have to do is we're going to have to extend the var node tracing functionality that I had. That way you can effectively see that, hey, well, first off, you can already see that due to the functionality I have, that this pointer, this is a pointer that is being added within a loop. We just need to have it so we can say that, hey, this value is also derived from this OXB008. Also, for context purposes, what a multi-equal P code is it's effectively saying, hey, this value can be derived, this var node's value can be derived from these two var nodes, and the reason why it does that is this var node right here, OX3100, is where the pointer initially gets dereferenced, which corresponds to that line of code. Cool. And then once we establish that I can trace through this multi-equal, then when it gets to the store instruction, I can see that. So let's go ahead and have that. First off, let's see, do we already have code for a multi-equal? We do, but I get the feeling this is in iterate until call. Multi-equal, this is an iterate code path. Okay, so we've seen that it looks like it already has that functionality. So something is probably wrong. Let's go ahead and throw in some print statements. But before we do that, I'm going to get rid of this print statement right here since we no longer need it. And if we don't get rid of these old print statements, then pretty soon our output is just going to be filled with a ton of text we don't care about. So let's first see if it can just say like, hey, this output is being incremented. Out.println var node output pointer. Let's throw in some new lines to make it easy to spot from the output text. Where's my cursor? There's my cursor. Don't need to re-import it, so let's just go ahead and just process it. Okay, we see that it is indeed seeing this var node right here in the pointer at. That is good. That is what we like to see. Next, we need to let's check that the multi-equal is happening. I'm gonna pause the stream for a second. Okay, I'm back now. So this multi-equal, there's the output and the inputs. Iteration context put var node deals with this. Let's take a look. What is the actual like put var node? What does it actually do? Oh yeah, puts it that the source is equal to that. I'm gonna add a print statement here. System.out.println putting output to input. Let's go ahead. Oh, wait. Something's... Why? Oh, I forgot the plus right there. That's why it's yelling at me. Okay, let's try it now. This is interesting. So... Wait, is this in... Oh, this is in iterate until call, not... Right now I have two different functions for iterating. One will iterate over the entire function, the other will iterate until a function call. So this needs to go in the other multi-equal. This one right here. Okay, this should give us the output that we want. What could also be happening is this value could be interesting. Still didn't print anything. I'm just going to go ahead and insert a print statement here. Purpose being seeing if this switch statement is not the switch, this if the statement is actually being ran. Plus current P code. Let's go ahead and run this. So, this is interesting. This code is not being executed, which means either for some reason this conditional is not detecting if something is a multi-equal, or for some reason it's not iterating to that one, which I can't think of why. To see if which one it is, I'm just gonna print out the P code that we're looking at. Okay, let's see what this comes up with. Wait a second. Oh my gosh, I'm still smooth brain out. It's the other multi-equal. This is what I get for having two identical pieces of code. Okay, here we are putting. Now, how does this putting value work? Okay, it just adds it to the list. Okay, so this one should be mapped to these two separate ones. So I think the multi-equal is working. So let's look at the actual, what was the var node? The store var node. And conditional branch store. Let's first make sure that we're getting the is stored. So first, just make sure that this piece of code is running when we expect it to. Of course, I made a typo mistake. Storing loop. Okay, what it probably is this what is it? This dot iteration context dot is incremented pointer is so we see here just checking that like so with the where is it called? The pointer add where is it? It just marks that hey this pointer is being incremented. However, what we need to do is you also need to iterate through all of the what do you call it? The var nodes where it defines its value from and see if any of them are also. So let's turn this into an if that is if this statement is true, we return true, and then we can also iterate through array list var node source list equals this dot where is it var node mappings dot get or default pointer var node null if source list is equal to null return false, and then we just iterate through for each var node current var node in source. Excuse me. We can just check if this dot wait what is it? This dot incremented pointers dot contains current var node. Add a print statement here just to make sure it's the correct one. var node incremented plus current var node, and then we can return true, and then add a return false statement here for all the ones that didn't get caught. Now let's go ahead and run it now. Let's see if this works. Okay, it did not work. Is it iterating through all of the var nodes correctly? Actually, wait a second. I'm going to add a print statement here to also look at what the source var node is, and the other print statement I added was to see the to see the var nodes that it's tracing its value from. Let's do that and go ahead and run it. Let's see if this works. Looking at this value, and it's, yeah. Incremented pointer add. So what I'm thinking here is, it's clearly looking at the var node that is being incremented, but it's not in the hash set that is like where incremented pointers should be stored in. So I'm just throwing in a print state incrementing. So this is a bit interesting. I think I see what the issue is. I'm gonna pause the stream and then explain it after that. Okay, so the thing that we can see here is when it looks at the var node, it's after or before it actually sees that it's being incremented. Which, if you look at here, the conditional branch is occurring here. It gets stored, and where's the pointer at? Pointer at occurs. Yeah, store happens here, pointer add happens here. So, yeah, the pointer add is occurring after the store, at least in the loop, so that's how the code iterator is seeing it. So, what we can see here is we might be able to see out the print line dereferenced. How can I do this, I wonder? So, well, how did I do this beforehand? Pointer add, store. Okay, so before, how I deal with this issue was I just keep track of the pointers that are being dereferenced and see what they are being dereferenced as. However, here, issue with that being that the value that is being stored as the output is different than this. So what I could do, I have several different options I could do here. I could create some sort of new data structure that would effectively keep track of these, well, dereferenced. How could I do this? Here's also another problem that we could potentially run into is when we run through this entire code, like this is a potential problem I just thought of also that we have to deal with. The point, even if this value is being dereferenced or being calculated, there could be some additional logic that moves it to another variable, then another variable, and then back to the pointer that we cannot see here. So we need to either, there's two ways I can think of how we can solve this problem. First is that we iterate through this loop once, um, gain basically knowledge as to like, oh, iterate through this particular code path in this particular way once, gain knowledge as to like, hey, this variable ends up here, this variable ends up here, or we have some sort of data structure that effectively any time that a pointer gets incremented or a value gets moved, we can then look it up in a data structure to see, does it somehow maybe one or two jumps away, does it end up in a spot that we actually care about? Well, this video's been going on for 45 minutes, so I'm going to go ahead and cut it off here. Thank you for watching.